Hello and welcome back. So let's start with the today's session. So what we are going to do today, first of all, let me remind you what we did in last video. So we looked at the orthogonality of the subspaces, right? हम लोगों ने ये देखा कि how two subspaces are orthogonal, right? And अगर दो subspaces orthogonal है, then we looked at कि दोनों सबस्पेस से आप वेक्टर्स को पिक करो and you will find that they are also orthogonal or their dot product between them will be zero, right? So after that we looked at the subspaces, we looked at the four subspaces and we found the orthogonality relation between these four fundamental subspaces, right? And we got to know that which subspaces are orthogonal, right? जैसे कि अगर आपके पास if you have the column space, then column space is going to orthonormal to the left null space and the row space is orthogonal to the null space and vice versa, right? So what we are going to do today, we are going to look at the complement of the orthogonal, right? So it is just a term, so I just need to make aware of it, otherwise you already know what is the complement of a subspace. So today basically we will be focusing on that, and we will take an example where we will try to find a complement given a space, or you can say given a subspace. What will be the orthogonal complement of that particular subspace? So basically today agenda is to cover the orthogonal complement. So let's start with the today's session.
ओके लेट्स स्टार्ट विद दिस ऑर्थोगोनल कॉम्प्लीमेंट। तो ये ऑर्थोगोनल कॉम्प्लीमेंट है क्या? मान लो कि कोई भी आपके पास वेक्टर स्पेस वी है, राइट? अगर मैं पूछूं कि व्हाट विल बी द ऑर्थो कॉम्प्लीमेंट ऑफ दिस वेक्टर स्पेस वी, सो लेट मी फर्स्ट ऑफ ऑल कॉल दैट ऑर्थोगोनल space as a v per, right? And if this space is orthogonal to this space, तो लास्ट वीडियो हम लोगों ने देखा था कि अगर इस स्पेस से मैं कोई भी वेक्टर पिक करूं और इस स्पेस से मैं कोई भी वेक्टर पिक करूं, देन दिस टू वेक्टर are going to form an angle of 90 degree or their dot product will be 0, right? So what is this orthogonal complement? So this orthogonal complement is nothing, just a space. If I talk about this particular vector space, then its orthogonal complement will be v per. We are denoting it as a v per, and this vector space will consist of all the vector that are perpendicular to the all the vector from this particular space v, right? So अगर कोई पूछेगा कि अगर आपको orthogonal complement निकालना of a particular vector space, then what you will do, you will find a vector space, you will find a orthogonal vector space, right? That is all that you need to do, right? So if I have to formally introduce the definition for this orthogonal complement, then this is how I can write. So the orthogonal complement of a vector space v is the स्पेस. सो ऑर्थोगोनल कॉम्प्लीमेंट को मैं बोल रहा हूँ वी पर और वी परपेंडिकुलर, राइट? सो जो ऑर्थोगोनल कॉम्प्लीमेंट स्पेस है दैट आई एम डिनोटिंग विद द वी पर. सो दिस वी पर विल consisting of all vectors perpendicular to v, right? So if we have this vector space v, and if it belongs to or is a subset or is a subspace of this n-dimensional space, then the orthogonal complement or the v per will also be a subspace or the subset or the subspace of this r to the power n dimensional space, right? This is the first point. And अगर मेरे पास ये वेक्टर स्पेस है दैट इज द ऑर्थोगोनल कॉम्प्लीमेंट, अगर मैं उसका कॉम्प्लीमेंट लूँ, लेट सपोज यू हैव दिस वेक्टर स्पेस that is the orthogonal complement of this vector space B. Now if I find the orthogonal complement of this particular vector space V per, then I will get back this vector V. So this vector space V, right? Now how we can tell that two subspaces will be orthogonal complement, right? So कैसे कंडीशन क्या होगा कि किस किस तरह से हम पहचानेंगे कि दो अगर गिवन सब स्पेस है देन दे आर द ऑर्थोगोनल कॉम्प्लीमेंट, राइट? सो वी कैन आस्क अ क्वेश्चन मे बी हाउ कैन वी टेल दैट two subspaces of the same vector space are orthogonal complement. तो देखो सो सबसे जो फर्स्ट कंडीशन होगा ना कि अगर दोनों ऑर्थोगोनल कॉम्प्लीमेंट है, इफ टू सबस्पेस ऑर्थोगोनल कॉम्प्लीमेंट, देन फर्स्ट कि दोनों सबस्पेस शुड बी ऑर्थोगोनल, राइट? सो द टू सबस्पेसेस need to be orthogonal, right? एंड इन लास्ट लेक्चर हम लोगों ने देखा था कि what is this to be two subspaces to be on orthogonal, right? Now the second thing is that जैसे कि अगर आपने लास्ट वीडियो में भी देखा होगा कि अगर टू सब स्पेस ऑर्थोगोनल है, राइट, एंड इफ दे बिलोंग्स टू सम n dimensional space, right, then their dimension will add up to the complete dimension, right? So if the dimension of this particular subspace is R, then the dimension of this subspace will be n minus R, and if we add up then we will have again this complete dimension, right? So अगर दो subspaces orthogonal complement है then they are going to be orthogonal. that is the first point. सेकेंड पॉइंट क्या है कि उनके अगर हम डायमेंशंस को ऐड करें देन यू विल गेट बैक द कंप्लीट डायमेंशन, राइट? उनके डायमेंशन को जैसे ही आप ऐड करोगे you will have the complete dimension, right, where they belongs to, or right? So the second condition would be if the dimensions add up to the dimension of the space that contains them, राइट? सो लेट्स सपोज कि अगर आपके पास कोई वेक्टर स्पेस है V जिसका कि डायमेंशन k है, राइट, एंड देन और लेट्स सपोज कि दोनों वेक्टर स्पेस r⁴ n डायमेंशनल स्पेस में है, देन जो इसका डायमेंशन होगा V पर का, दैट इज द ऑर्थोगोनल कॉम्प्लीमेंट ऑफ दिस पर्टिकुलर स्पेस वेक्टर V. सो इसका डायमेंशन क्या होगा n माइनस k. सो वी हैव सीन इन फ्रॉम द लास्ट वीडियो, राइट, बिकॉज these two subspaces are these two subspaces belongs to the same vector space, right? And if the dimension of this vector space V is k, then the dimension of this orthogonal subspace will be n minus k. Now if you add their dimension, you will get the complete dimension of this vector space, right? So if you add this, so k plus n minus k, so this is, you are getting n, and so n is the dimension of this complete vector space, राइट. तो ओवरऑल पॉइंट है कि लास्ट वीडियो में हम लोगों ने ये भी देखा था कि जो वेक्टर इस स्पेस से बिलोंग करेगा और जो वेक्टर दैट इज नॉट इन दिस स्पेस विल बी इन दिस स्पेस, राइट. और जो वेक्टर इस स्पेस में नहीं होगा दैट विल बी इन दिस स्पेस, राइट. Okay, now now we have this four fundamental subspaces, right. And we have already looked कि जो आपका रो स्पेस है, रो स्पेस इज ऑर्थोगोनल टू द null space, right. Or what we can say is row space will be so the orthogonal complement of the row space will be null space. Similarly, we have seen from the last video ki the column space is orthogonal to the left null space, or we can say that the orthogonal complement of this column space will be left null space, right. So let me write this point. So if we have this row space, then is the orthogonal complement of null space, right. And these two subspaces are in what dimension? So we have seen from the last video कि और मैंने काफ़ी अच्छे से डिस्क्राइब किया था कि these two subspaces are in the r to the power n vector space, right. Now the second point is that the column space is the orthogonal complement of left null space, right. And these two subspaces are in the m dimensional space, that is r to the power m, right. So लास्ट वीडियो में हम लोग ने ये भी देखा था ना कि आप कोई भी वेक्टर स्पेस, कोई भी रो स्पेस लो, सो रो स्पेस इज कोई भी रो स्पेस लो, ठीक है, और नल स्पेस से कोई भी वेक्टर पिक करो, रो स्पेस से कोई वेक्टर पिक करो, नल, those are going to make 90 degree angle, or you can say those will be perpendicular or their dot product will be 0, right. So ये लास्ट वीडियो हम लोगों ने देखा था. So और now introducing this orthogonal complement. Now what is this orthogonal complement? So according to definition, the orthogonal complement is going to contain all the vector that is perpendicular to so orthogonal vector space will contain all the vector that will be perpendicular to this vector space V, right. So अगर मेरे पास ये रो स्पेस है, if I ask you that what will be the orthogonal complement of this particular रो स्पेस, then we know कि मेरे पास नल स्पेस है that will contain the vector space that will contain all the vector that are going to be the perpendicular to the vectors that is in the row space, right. And these two subspaces are going to fill this complete n dimensional space, right, because we know the dimension of this row space is n, and the dimension of this column space is n minus, sorry, this dimension space is r, and the dimension of this null space will be n minus r. And if we add up these two dimensions, then we are going to get the dimension of this complete vector space where they belongs to, right. And similar thing for this the column space and the null space are true, right. So if I ask you what will be the orthogonal complement of this column space, then you know that all the vectors that are perpendicular to all the vectors that is in the column space are in the left null space, and they combinedly will, if you add the dimension of these two subspaces, you will get the complete dimension, that is r to the power m. So these two subspaces are in the same vector space, right. So overall point is that the orthogonal complement of this column space will be the left null space, right? So let me take an example, and if let me ask you that what will be the basis for the orthogonal complement. Let me first of all give it to you a space. Let's suppose कि आपके पास कोई space है. So how I can describe this space? Maybe with the basis. If I have the basis, then I have the space, right? So let's suppose कि आपके पास space है that are formed with these two vectors, or you can say the span of these two vector, or you can say the linear combination of these two vector. So you have this space V, right? And their bases are these two vector, and the complete space of this V is described by the span of these two vector, right? And obviously these vector will belong to some or the subset will be subset of this and 4 डायमेंशनल स्पेस. वाई? क्योंकि आप देखो ये दोनों वेक्टर कितने कहाँ से लिए गए हैं, 4 डायमेंशनल स्पेस से. ये वेक्टर कहाँ से लिए गए हैं, 4 डायमेंशनल स्पेस से. देन ऑब्वियसली इनका जो लीनियर कॉम्बिनेशन होगा विल बी इन द 4 डायमेंशनल स्पेस, राइट? सो दिस वी सब स्पेस इज इन द 4 डायमेंशनल space, or this V is a subset of this 4 dimensional space. Now can you give me the basis? So you have to find the basis for the, so find the basis for orthogonal complement, orthogonal complement subspace, or you can say V per. Find the basis for the orthogonal complement V per, right? Now given this question you have to understand कि आपको find क्या करना, what you have to find, right? So मेरे पास ये दोनों vector दिए हुए, right? Or you can say the basis of this vector space V, right? So I need to find a vector space that contains all the vectors that are going to perpendicular to all the vectors of this vector space V, right? So अगर if I have to think this in terms of matrices, right? Because matrices तो given है नहीं. If I have to think in terms of matrices, then maybe I will find something, right? And I can proceed with the solution. अगर मैं सपोज करो कि इसको जो मेरे पास ये जो गिवन वेक्टर है, ये अगर इन वेक्टर्स को मैं मैट्रिसेस में पुट कर दूं, और if I make matrices out of these vectors, right? So if I have to find the orthogonal complement, right? So what do I need to find? If I consider as these vectors as a column vector, so their span will be the column space, right? And if we have the column space, and we know from the fundamental theorem of this linear algebra, so these are called the fundamental theorems of linear algebra. So these are the second part of the fundamental theorem of linear algebra, and the first part was जहाँ पे हम लोगों ने डायमेंशन फाइंड किया 4 फंडामेंटल सब स्पेसेस का. सो दैट वाज द फर्स्ट part of the fundamental theorem of linear algebra, and this is the second fundamental theorem of the linear algebra, right? In first part we talked about the dimension of the 4 fundamental subspaces, and in the second part of that fundamental theorem of linear algebra we are talking about the orthogonal complements of these 4 fundamental subspaces, right? So now coming to this question, तो ये दोनों जो columns है, right? So what I have done, I have put these two vectors as a columns of this matrix. Let's suppose A, right? So the span of, or the linear combination of the columns of these will give you the column space, right? And we know from this theorem that the column space is the orthogonal complement of this left null space. So basically what I have to find is the left null space. If I have the left null space, then I have the orthogonal complement of this vector space V, right? We can think like this. Also we can think like this. Let's suppose we have given these two vectors, so we don't know if these are the column vector or the row vector. We can make use anyway, right? Whatever you are comfortable with. So maybe we can use with this as a rows of this vector as a row vector, and we can form a matrix like this, right? Now the span of the linear combination of these two vectors will give you the row space, right? And we know from the fundamental theorem of linear algebra, if we have the row space and if we have to find the orthogonal complement of this row space, then we have to find the null space. Basically then we have to solve for ax is equals to 0, right? And if we have this null space, then we have the orthogonal complement of this vectors, right? So anyway, so you can go either using this matrix, using this column space, or you can go from the like how we discussed uh, just now as a column vectors, right? So if you have the column space, then you need to find this left null space. Let me proceed with by making these vectors as a row vector. So हम लोग इसको row vector की तरह बना सकते हैं और row space की तरह. So we can assume that we have this matrix A and these vectors as a row vector, and their linear combination will contain the row space, will give you the row space, or their span will give you the row space, right? So 1 minus 1 1 0. Now if I have to find the null space, so if I have to find the v perp, right? So here this v vector space v will be the column space, right? Sorry, row space. And what will be the v perp? V perp क्या हो जाएगा यहाँ पे आपका? That will be the null space of this matrix A. So what we have to find is this null space. So इस क्वेश्चन में बेसिकली आपको क्या था कि मैट्रिक्स तो गिवन नहीं था, आपको वेक्टर गिवन था, ठीक है, और ये स्पेस गिवन था, दैट इज द स्पैन ऑफ दिस वेक्टर. सो बेसिकली आपको यहाँ पे ये आपको रिकॉग्नाइज करना था ना कि आई हैव टू फाइंड दिस नल स्पेस. इफ़ यू आर टेकिंग दिस वेक्टर एज अ रो स्पेस, देन यू हैव टू फाइंड द नल स्पेस, right? So how we can find the null space? We know that we can proceed with the elimination and we can solve for ax is equals to 0. So we need to have all the vectors or the vector space that contains all these x's, or in one word we need to find the null space. So we can proceed with the elimination. We can take this as a pivot and we can apply the elimination steps. That is, the first step is r2 minus r1, that will go to r2, and we will have this vector, we will have this matrix. So here we will have 0, and now here minus 1 and minus 2 minus 3, 1 minus 3 is minus 2, and minus 1 minus 4 is minus 5, right? So now we have two pivots, that is this one and this one. We cannot have more than these more than two pivot, right? So null space find karna, then we are going to look at the free columns, or you can say the free variables. So free variables आपका कौन कौन होगा? x3 होगा and x4 होगा, right? So दो स्पेशल सॉल्यूशन मिलेगा. लेट मी राइट फर्स्ट स्पेशल सॉल्यूशन. सो x3 को मैंने 1 कर दिया, x4 को मैंने 0 कर दिया, राइट? सो इफ आई पुट x4 0 and x3 1, so minus 3 minus 2 is equal to 0, minus 3x2. So from here x2 will be 2 by 3, minus 2 by 3, right? So x2 will be minus 2 by 3. Now we need to find this x1, so we can do the back substitution. So this one 0, so this will be 0, 3 plus minus 4 divided by 3 plus x1 is equal to 0. So overall we will have x1 is equals to so here we will have 3 minus 4 plus 9, so minus 5 by 3, right? So x1 will be minus 5 by 3, right? So this is the first special solution corresponding to this column when we have taken this 1 0. Now अब हम क्या कर सकते हैं? मैंने x3 को 1 लिया था. Now we can take x4 as 1 and x3 as 0, and we can again do the back substitution to find this x2. So this is 0 now, so we will get minus 5 by 3. x2 will be minus 5 by 3, and what will be the x1? So we can do again the back substitution. So this will be 0, this will be 4, so minus 10 divided by 3 plus 4, right? So here 2 divided by 3, so overall we will get minus 2 divided by 3. So minus 2 divided by 3, right? So what will be the v per orthogonal complement of this vector space V will be the span of, or the linear combination of, these two vectors, or you can say directly the null space, comma, minus 2 divided by 3, 5 divided by 3, 0, 1. So this is the one way we can find this. Another way we can, what we can do, we can find this left null space, right? So let's do that also. So अभी हम लोगों ने क्या किया था ना कि वेक्टर ए का जो फॉर्मेशन किया था by considering this as a row vector. Now even we can have this, maybe let's call this vector b, or so now अब हम लोग क्या करेंगे, इस वेक्टर को हम लोग एज अ कॉलम वेक्टर कंसीडर करते हैं. So now we will have 1 minus 1 1 and 1, right? So in that case we will have to find the left null space, and how we can find the left null space? By tracking the elimination steps, right? Because मैंने काफ़ी अच्छे से आपको समझाया है कि लेफ्ट नल स्पेस क्या होता है, राइट? सो ऐसा रो कॉम्बिनेशन जो कि मुझे जीरो प्रोड्यूस करे, जीरो रो प्रोड्यूस करे. So I need to find those combination. I need to find all those combination of rows that is producing this zero. And we so last time मैंने इस पर भी डिस्कस किया था कि प्रोसीड्योर क्या फाइंड करने का, हाउ यू कैन ट्रैक दोज कॉम्बिनेशन. सो बेसिकली हम लोग करते क्या, हम लोग सिंपली इधर लेफ्ट साइड में आपको दिस b1 b2 b3 b4 ले लेते हैं. जस्ट वी नीड टू ट्रैक कि कौन सा एलिमिनेशन स्टेप जो है मुझे जीरोज देगा रोज में, राइट? सो आई एम नॉट गोइंग टू टॉक अबाउट ऑल दिस थिंग, राइट? बिकॉज I will be repeating again the same thing, right? So यहाँ पे जो आपका सबसे पहली बात तो जो v होगा वो क्या होगा, वो होगा कॉलम स्पेस, राइट? एंड व्हाट विल बी द v पर विल बी द null space, left null space, right? So we need to find this v per, right? So to find this v per we are going to track the elimination steps, and so we can consider this as a pivot, and we can apply, और इसके नीचे जितने भी एलिमेंट्स होंगे सबको जीरो करेंगे. सो वी विल हैव द स्टेप्स r2 minus 2 r1 that will go to r2, and r3 minus 3 r1 that will go to r3, and r4 minus 4 r1 that will go to r4, right? Now after doing that operation, फर्स्ट रो तो एज इट इज़ रहेगा, सेकेंड रो में यहाँ जीरो आएगा, यहाँ पे कितना आएगा -1 एंड -2, सो वी विल हैव -3 हियर. लेट मी डू ऑन. सो ये बी हम लोगों ने क्यों यहाँ आर्गुमेंट किया है, रोज की जो कॉम्बिनेशन है ना उनको ट्रैक करने के लिए, या नहीं तो आप एलिमिनेशन से भी ट्रैक कर सकते हो, एलिमिनेशन मैट्रिसेस से भी, राइट? सो ये लास्ट वीडियो में मैंने बताया है कि हाउ टू फाइंड द लेफ्ट नल स्पेस. सो यू कैन गो थ्रू दोज वीडियोज. सो हियर वी विल हैव b2 minus 2 b1, राइट? हियर वी विल हैव 0 and 1 minus 3 is -2, and b3 minus 3 b1. Here we will have 0, here we will have 1 minus 4 is -3. Here -1 is right, yes. So यहाँ पे 5 आ जाएगा, -5. So b4 minus 4 times of b1, right? Now we can have this second pivot also. This is the first pivot, and we can eliminate all this, right? So what will be the elimination steps? So elimination step will be r3 minus 2 by 3 r2, that will go to r3, right? And R4 minus 5 by 3 R2, that will go to R4, right? And after doing this operation, we will have the matrix. First row will be as it is, second row will be as it is, and the third row we will have here 0, we will have here 0, right? And so here b3, so what we are doing is row 3 b3 minus 3 times of b1 minus 2 by 3 b2 plus 4 by 3 b1. So 9, so here b1 is there, here b1, right? So 9 minus 9 plus 4, that we are going to get is 5 by 3 b1 minus 5 by 3 b1 and minus 2 by 3 b2 and plus b3, right? So minus, okay, so we will have here minus 5 by 3 b1 minus 2 by 3 b2 and plus b3, right? Again here we will have 0 0 and यहाँ पे क्या हो जाएगा आपका b4 minus 4 b1, so minus 5 by 3 b2 plus 10 by 3 b1. So b1 is there, b1 is there, so 12 plus 10, so minus 2 by 3 b1 और बाकी अदर तो उतना ही रह जाएगा, minus 2 by 3 minus 5 by 3 and b4. Okay, so here we will have minus 2 by 3 b1 minus 5 by 3 b2 and plus b4, right? So we have got the rows of 0, this one and this one. So what combination is producing these rows of 0, वो कहाँ से मुझे मिलेगा, वो इन दोनों से मिलेगा, राइट? सो अगर ये लेफ्ट हैंड साइड में 0 है तो राइट हैंड साइड में इसको भी 0 होना पड़ेगा, राइट? सो व्हाट्स द कंडीशन? देखो मैट्रिक्स ई एलिमिनेशन जो है मेरे पास, जो हम लोग एलिमिनेशन मैट्रिक्स कैसे फाइंड करते हैं, राइट? तो एलिमिनेशन मैट्रिक्स अगर अप्लाई हो रहा है दिस मैट्रिक्स ए पे, उसको मैंने कहाँ पे ट्रैक किया, हियर, राइट? सो द रोज ऑफ दिस मैट्रिक्स ई विल गिव यू दैट व्हाट कॉम्बिनेशन, व्हाट रोज कॉम्बिनेशन of this A is producing these vectors 0, these rows vector 0, और ये information कहाँ पे, E पे है, और E कहाँ है, E is nothing but this matrix, right? So these rows of E are producing these 0. So what combination of rows is producing 0? So these combination are producing the 0, and that is in the left null space, right? And their linear combination will give you the complete left null space, right? So I can say this V perp or this left null space will be the linear combination of these vectors. So b1 is minus 5 by 3 and b2 is minus 2 by 3 and b3 is 1 and b4 has no component, so it is 0. So this is your first vector, and the second vector is minus 2 by 3 minus 5 by 3, b3 is 0 and b4 is 1, right? So span of these two vectors will give you this left null space, and this left null space is nothing but the orthogonal complement of this particular vector space V that we have considered as a column space, right? So you can solve. So it depends on कि आप इन वेक्टर्स को कैसे देख रहे हो, एज अ रो वेक्टर, एज अ कॉलम वेक्टर, राइट? अगर रो वेक्टर एज अ रो वेक्टर की तरह देख रहे हो, देन यू नीड टू फाइंड जस्ट द नल स्पेस, राइट? एंड अगर इफ़ यू आर लुकिंग एट दीज एज अ कॉलम वेक्टर्स, देन यू नीड टू फाइंड द लेफ्ट नल स्पेस, एंड दोज विल गिव यू द complement of this particular vector space V, right? Okay, now I think you would have the good idea about this orthogonal complements, right? Also, just to mention, these are the fundamental theorem part 2, and we talked about the dimension also, right? In I don't know in which video, but those are the fundamental linear algebra fundamental theorem part 1, right? So that is not important, but you just need to understand what is what, that is important, right? Okay, that is all I think in this video. We will I think talk about the projections in next video, this one.